Hello, pre-calculus students and seekers of truth. In this video, we will continue our study of sinusoids by looking at some horizontal features of it. Okay, so again, we're looking at horizontal features of it. And one of the features is called the period, which is how often the function repeats itself. You can clearly see that all sinusoids repeat themselves. They're just waves. They go up and down, up and down, up and down. And the question is, how long does it take for one of these waves to start repeating itself? And this can be kind of a tricky question because it's hard to determine, well, where do we start and where do we end? This wave is infinitely long. And so it's kind of hard to tell where does it start. Well, I like this. There's two ways you can look at it. One way is you can start with the origin, right? So you can look at this wave here as starting at the origin, out of the middle of the wave, I should say, right? And it's going to go up, and then it's going to go down, and it's going to go up, and right there, right at this point, the second point right here, let me highlight this with a color that's easy to see, right? At this green dot right here, and this other green dot, you can say that between those 2 points is where the wave starts to repeat itself. Okay, so from this picture you can clearly tell that the period is 2 pi. So the period of the parent function is 2 pi. Okay, and another way that we could also tell is by using what I call the min to min or max to max. If we look at this wave here, it has, in one period, it has precisely one maximum and one minimum. So if we look at this from one maximum to the other maximum, the horizontal distance, right? And keep in mind, this is all horizontal stuff, so we don't care that it's a max of 1. That doesn't affect the period at all. It's really that this horizontal distance, this is 5 pi over 2 minus pi over 2. So we can say from max to max. Okay. It has a distance of 5 pi over 2 minus pi over 2, which is 4 pi over 2, which is equal to 2 pi. Okay, so there's a number of different ways that we could do this. One way is just to look at the graph and see how long that it's going to repeat. The other way is to look at the horizontal distance between two maximum points. Okay. In science term, this is from crest to crest, from the highest point to the next to the consecutive highest point. Or you could also do the same thing from minimum to minimum. But the point is that the period of the parent functions for sine and for cosine, it is 2 pi. Okay, the other thing that you should think about is, why is it 2 pi? Well, let's think back about, where did this graph come from, right? This graph is really a generated graph from the unit circle. So we start out here at theta equals 0, right? And so what we're really graphing along the horizontal axis here is theta, and what we're graphing along the vertical axis here is the sine of theta. So, once you make it a full unit circle all around, you've gone through pi over 2, you've gone through theta equals pi, you've gone through theta equals 3 pi over 2, and then you're back around here. And at this point, theta is equal to 2 pi. So every 2 pi radian, this graph is going to repeat itself, right? At least the parent function. Without any transformation, the graph repeats itself every 2 pi unit. So that's the period of the parent function. Now we're going to continue and talk about what are the periods of some of the other graphs here, right? So find the period of the following functions. We have sine of 2x, cosine of pi over 6, cosine of x over 3. All right, and before we start graphing stuff, I'm going to remind everybody the period for the original function, the parent function, is 2 pi. Okay. And then we can talk about transformations. What is this 2 right here doing in, to the function? It's modifying the input, so it's going to modify all the horizontal changes. So this is going to be a horizontal. And remember, all of the horizontal stuff is sort of counterintuitive or backwards. So it's the horizontal shrink of 1/2. Okay, so however big the original graph is, it's going to be half of its size. So so for f of x is going to have a period that is equal to the original period, 2 pi, times 1/2, or divided by 2. So it's going to have a period of pi. Okay? And we will graph all of these in a little bit so that you could see them. The next one that I'm going to look at is the cosine graph here. And actually, I'm going to jump to h of x next because that might be a little bit easier for us to visualize. So we have x over 3. And so I think it might be easier if I rewrite it this way. This is 1/3 times x, right? And so again, this is going to be a horizontal change, but this time it's going to be a horizontal stretch. Right? Everything that is dealing with the horizontal is kind of backwards or counterintuitive. It's a horizontal stretch of not 1/3, but of 3. So for h of x, our period is going to be equal to 2 pi. Right? We always start out with 2 pi because that's the parent period, times 3, which is going to equal 6 pi. And so now, before I go on and graph the function for answer the question for g of x, let's look at a graph of f and a graph of h here. If you have your calculator, go ahead and pull those out and graph them, and let's see what exactly is happening to the graph. Alright, so I've inserted the graph of f of x into our picture here, and you can see that it's still a wave, right? It's still a sine wave, but let's look at what's going on here. One way that we could do is we could measure the distance between two maximum, right? So this is from pi over 4 to 5 pi over 4, so max to max, or crest to crest, to use some scientific terms. That is a distance of pi over 4. It goes from pi over 4 to 5 pi over 4. So if you subtract these two, you end up with 4 pi over 4, and that's equal to exactly just pi. Okay. And then I've gone ahead and also graphed this one more time, except you could see the purple wave here. So let's clarify here. The red wave here is still f of x, which is sine of 2x. And then the purple wave is the original function, right? So this is f of x is equal to sine of x, right? So you can see that relative to the purple wave, the red wave has been shrunken to half of its original size, right? So instead of a period of 2 pi, it's a period of pi instead, right? And I'm going to add one more picture here so that you can see what h of x looks like.